All right, guys, we're ready for section 1.2 for survey of data. And this section is all about expressions. So we're first just going to start off by giving a definition to that word expression. So what exactly is it? So in 1.1, we talked about constants versus variables, okay? So expressions just put operations with that. So your addition, subtraction, multiplication, and division. So expressions now are just variables or you can have one or the other, constants, and the operations between them. Okay, so that is what an expression is. So what we're going to be doing in this section is evaluating expressions and trying to come up with expressions that represent real life scenarios. So the first thing we're going to do is start with kind of the simpler version of that. And we're going to start with just evaluating expressions. So we can both get used to how expressions look and just how to work with them. So we're going to be given an expression and then we're just going to evaluate that expression. So here is an example, okay? Actually, we're going to look at several examples here, okay? Our first one is to evaluate. Here's our expression, x minus 4. We have a variable x, we have a constant 4, and we have the operation of subtraction between them. So that's an expression. We're going to evaluate that expression for x equal to 7. So that just means we want to take this x equal to 7 and plug it in for the x in our expression and actually then carry out that operation. So the answer here would be to take 7 minus 4, which we can do hopefully in our heads, and 7 minus 4 is 3. And we have evaluated that expression x minus 4 for the value x equal to 7. Okay, so that's what we mean by evaluating an expression. So again, in these examples, you're just going to be given expressions and you want to evaluate them. So let's look at a different operation. 2m is also an expression. Again, our constant here is 2, our variable is m, and we have an operation between them, although we haven't written an operation down. When you don't see one between two things, it's multiplication. So here we're taking 2 times m, and we want to evaluate that for m equal to 4. Okay? So again, what I'm going to do is take that 4 and plug it in for m. I don't see an operation there, so often what we'll do is put parentheses to also show multiplication. So that also means 2 times 4, and 2 times 4 is 8. So we have now evaluated the expression 2m for m equal to 4. And we're done. All right, so we're just going to try a couple more here, looking at some different operations and some different ways that these things can look. So can you evaluate 80 divided by y for y equal to 2? Okay, so again, just take that 2 and plug it in for y. So we have 80 divided by 2. Another way we often see division, if this makes a little more sense when you're trying to calculate this, is 80 divided by 2, like that, either way. Either way you look at it, 80 divided by 2 is 40. And so we have now evaluated that expression with division to be 40. Now, we don't always have to have just one constant and one variable. We could have only variables, like we'll see in these next two examples. Okay, so in this one, we're going to evaluate x minus m for x equal to 20 and m equal to 5. Okay. So now we have 2 different variables to plug in to evaluate our expression. So we want to make sure we keep track of those. Okay, so x is 20. That means I'm going to plug in 20 here for x. So I'm going to take 20. I'm going to subtract m. M is 5, so that's what I'm going to plug in here. So I want to evaluate 20 minus 5. 20 minus 5 is equal to 15. And I can evaluate an expression with two variables and an operation between those two. Expressions can have unlimited amounts of constants and variables. We're just trying to keep it simple here as we're learning the concept. One last one. So this one will be a good one to try. Once you see it, maybe pause the video, give it a shot, see if you get the right answer. Can you evaluate x divided by y for x equal to 16 and y equal to 8? Okay, so again, take the time to plug those in and see what you get. Hopefully you got the 16 in your numerator, right? That's the top of your fraction, divided by 8 should be in your denominator, and 16 divided by 8 is 2. So your final answer to evaluate that expression for the variables given should be 2. All right, so hopefully that helps you learn how to evaluate expressions, how to evaluate expressions. And now I just want to look at an expression in context, okay? So we use these expressions all the time to represent more complicated scenarios if we start talking about writing those scenarios out. So here is an example where we have some context to that expression, okay? So we're going to have a person who buys N shirts. Okay, so we now have a variable introduced. N is our variable, and it's the number of shirts this person buys. And they're going to buy these shirts for a total cost of 15N. So now we have an expression involving that variable. 15N is our expression, and that is representing the cost that the person has to pay for buying this certain number of shirts. So what I want you to do is first evaluate the expression for N equal to 2. And then what we're going to do is interpret that result, understand what we are doing actually when we put 2 into that expression. So interpret your result as the last step. Okay, so let's go back to part A. We want to evaluate the expression. So the expression is 15N for N equal to 2. So that's just what we were doing before, right? So the key thing here is to realize that 15N is the expression. It's the one with both a constant, a variable, and an operation between them. So for this part, we're going to take 15 and we're going to plug in N equals 2. Again, I'm going to use those parentheses to remind myself that I'm doing multiplication here. 15 times 2 is 30. And so we've gotten 30 there. Now, before that's where we had to stop because the expression itself didn't have any context. But since this one has context, we know that this 30 has units to it and it means something in the context of this problem. So our final result would be, okay, what did we do? We plugged in 2, and that meant we bought 2 shirts, right? So we plugged in 2, that meant we had 2 shirts, and we got a total cost of 30, meaning we spent $30 on 2 shirts. And there we go, we've interpreted our result. So I'm gonna write that out. What happened here? The person bought 2 shirts for a total cost and put that unit to it. We know when we buy things, it's in terms of dollars. So for a total cost of $30. And we've interpreted those 2 numbers that we used in that expression. Okay, so anytime you're in context, always go back and make sure you understand what the numbers you're getting mean in terms of that particular setup. All right, we're going to do another in context one here where we're going to actually come up with the expression. But before we start to come up with the expressions, it's helpful to talk about translating back and forth from those expressions and from the way we talk about those expressions kind of in our English language. Okay, so we want to talk about translating from our words, our English, to the expression. So basically translating from words to math, right? How do we do that? And there's all different types of scenarios you're going to kind of come across here. So what I'm going to do is just kind of give you a general table of things that typically come up. So this is not going to cover everything, but might be kind of helpful. So anytime we're talking about operations, what are some words we typically use? So let's start with the operation addition. What are some typical words we'll say in our English language to represent addition? Okay, so what's an English word or possibly even a phrase that we use when we're adding two things together? So your most common one, your most obvious one at least, is add, right? If I say to add two things together, I know my operation is addition. Sometimes I'll say plus for addition. Sometimes I'll say sum. The sum of two things means I'm adding them. If I say 3 more than something, then I need to add 3 to it. So more than can mean addition. And another common one is if I increase something. So if I increase something by 3, that means I add 3 to it. Okay, so just some typical phrases there. Again, not an exhaustive list, but some things to look out for that mean addition. Subtraction. Some common things that mean subtraction. We talk about subtraction as minus two numbers, or the difference between two numbers. The difference, if I want to find the difference between 5 and 2, I need to take 5 minus 2. The obvious one is just to subtract. Just like with addition, if I take 3 more than something, that means I need to add 3 to it. If I take 3 less than something, that means I need to subtract 3 away. So less than is a common phrase that means subtraction, and decreased by. Now I will note here before we move on to multiplication and addition, the ones I see students kind of get tripped up by the most are this more than and less than. So it can get a little confusing because remember, more and less are also inequality signs. So always make sure that you look at the whole context of the problem. Are we just saying that 5 is greater than 3 and using the word more to say that? Or are we saying that 5 is, we need 5 more pizzas? That means I need to add 5 more in, okay? So always look at the entire context of the problem. All right, moving on from that, we also have multiplication that can be talked about in English words and phrases. The most obvious one here is if you see the word multiply, but less obvious, if I say two things times each other, that's multiplication. The product of two numbers is multiplied. One that's very common but kind of hard to remember is if I say twice something, then I want to take 2 times it. Or if I say I want a half or a third of something, that means I need to take that fraction times whatever I'm looking at. Okay, so anytime I talk about twice something or a third or a half of something, and anytime I'm saying that, you'll hear I'm kind of dropping that word of a lot. So when you see of between talking about two numbers, a lot of the time it's a tip off for multiplication, or that multiplication is going on. And our last operation is division. Divide is your obvious one. Past that, quotient. The quotient of two numbers means to divide the two numbers. The ratio of two numbers means to divide two numbers. And kind of like multiplication has of, if you see per in units or something like that, that often means that division is going on. Okay, so again, not exhaustive lists here, but just some things to look out for to help you start translating, coming up with those expressions to represent scenarios. Okay, so we're going to start off with kind of some basic ones here just to kind of get used to this list. And then we're going to look at one where we need to come up with that expression in context. So these first ones aren't going to be quite in context yet, but we just want to get used to coming up with those expressions given words. So in these examples, I want you to translate each phrase to an expression. And we really like to do that in math to make things simpler, to get rid of all the words and condense it down to just an expression. Okay, so can you translate this first one? The product of 6 and a number. So a few things going on here. We're going to translate this into an expression. So the first thing we see is the product. Right there, that tells us that we're going to have multiplication going on. That's not an x variable. That means that we're multiplying the two numbers. Okay. The two numbers we're multiplying, the product of 6 and a number. This means I need a variable. And I can make that, it doesn't say what my variable has to be. I can make it any variable I want. So the most common variable we use is x, right? So that's what I'm going to use here. So I need the product of 6 and a number. That means I need to take 6 times a variable. That could look like 6 times x. Or that could be the variable times 6, because we can multiply in either order. A little dot like that will often represent multiplication. We tend to, once we hit expressions, get away from using that cross, basically an x, to represent multiplication, because that can get easily confused with the variable x. So typically we'll either not write an operation for multiplication, or we'll use one of those little dots for multiplication. Okay, so two different ways to represent this expression. Okay, both of these are perfectly correct, because again, we can multiply in any order and the product will still be the same. The next one here, the quotient of 7 and a number. Okay, so we're starting to recognize some things that are similar and some things that are different. So if you look back up at your list, quotient means to divide. And this time we're going to divide 7 and a number. Again, this means I just need a variable. And again, you can use any letter you want here. I'm just going to stick with x to keep it simple. Now this time, it is very important I do this in the order that the sentence says. The quotient of 7 and a number means 7 divided by x. Or you can use that division symbol, 7 divided by x. That is not the same thing as x divided by 7. I cannot switch those two things around, because if I divide two things in a different order, I get a different result. So you have to do it in the order that the statement says. The first one is always the number on top, the numerator. The second thing said is always the number on bottom, or the denominator. So both of these answers are correct, just two different ways to write division, but very important that the 7 comes first or is on top, and the x comes second or is on bottom. All right, 12 more than a number. Okay, if I have 12 more than a number, so that's not saying 12 is greater than a number, right? I have 12 more than whatever number I'm already at. So this is where I'm adding. This is addition. I'm going to take 12 and add a number. This is, again, is my variable, and I'm going to use x for it. So I take 12, and it's 12 more than whatever number I was at. Or, since again addition is one of those operations I can do in either order, I could also say x plus 12 for this. Either way is perfect. This next one is a little bit trickier. A number less than 5. So again, I'm not saying the number is less than 5. That would mean I have an inequality, right? I'm taking a number and I'm taking that number less than 5. Okay, this one's always kind of the most confusing one when people see this less than. So a number less than 5. So kind of sometimes if you get confused with this variable sitting in here, this a number, think, okay, I need to take 3, put a number in there. 3 less than 5. That means I need to take 3 away from 5. I'm going to take a number away from 5. So my operation is to subtract. And my variable, I'm going to use x, and my number is 5. Now, with addition, we didn't have to worry about the order. With subtraction, we do. Now you want to, kind of your typical thing here is to read it from left to right and to write the expression from left to right. But that would be wrong. If I write down x minus 5 here, what am I doing? I'm taking 5 away from a number, so I'm taking 5 less than whatever x was. But I want to take a number less than 5. So this is incorrect. Instead, what I want to do is I want to take 5 minus the number. I want to take the number less than 5. And there we go, we have our expression. Cannot be written the other way. That would be an entirely different expression and an entirely different result. Okay, you'll have a lot of good practice with that in the homework, so make sure you look at that. We want to look at one last example where we kind of put all of this together in context, where we have to come up with the expression, evaluate it, and finally interpret our result. So one last big example, not expression. Look at me, I'm writing expression. This is one last big example. Okay. All right, so in our scenario, we have a total of, first variable is n, a total of n friends split the cost of a meal x, so x is the cost of the meal, and they split that cost equally. So we have two variables. They each mean a couple of different things. N is the total number of friends, x is the cost of the meal. And they want to split that cost of the meal equally. So what we're going to do is we are going to find an expression that describes each friend's cost. So after they split the meal, how much is each person going to pay? Once you find that expression, evaluate the expression for n equals 10 and x equals 200. And then the last thing you're going to do is interpret your result. Okay, so let's go back up to part A. A total of n friends split the cost of a meal x equally. Find an expression that describes each friend's cost. Now here's where we really have to think about this scenario. Even put a couple of numbers here. Okay, so if I bought a meal for $10 and I have 2 friends, keep it simple. How much would each friend pay? You guys know? If I bought a meal for $10 and I have 2 of us, then each of us are going to pay $5, right? And how did we get there? We took 10 divided by 2. So if we want to split up things equally, that wasn't in our list, but that's kind of a good tip-off for division. So I want to take that cost of the meal and divide it by the number of friends I have. And again, the order here is very important. The cost needs to be divided by however many friends there are in the group. Now, if we evaluate that expression for x equals 200 and n equals 10, then that means I need to take 200 divided by 10 You remember kind of your quick division there, the zeros will drop. 20 divided by 1 is 20. So I have evaluated the expression, but that evaluation means something because remember X and N have context in this problem. So go back and interpret your final result. What did you just do and what does it mean? So you took 200 divided by 10 because the total cost of the meal was 200 and we were dividing it then among 10 friends. So what's happening here? 10 friends split the cost of a $200 that has a cost is in dollars, a $200 meal, and each friend pays, our final result is how much each friend pays. Each friend pays $20. So we want to interpret that entire result. Sorry, that S there kind of got a little bit cut off. Okay, so always go back and think about what you just did in the context of the problem and make sure it actually makes sense, right? So if you had accidentally flipped X and N around here, then in part B, that would have been a good double check. You would have been trying to take 10 divided by 200 and you said, maybe that doesn't make sense. Maybe we couldn't buy a meal for 200 people that only cost $10, right? So maybe something is going on here and I've messed something up somewhere. All right. Okay, that's section 1.2. So go try the homework and then come in with questions, all right?